f of x equals x squared minus 5x plus 4 over x squared minus 4. So again, I'm looking for x-intercepts, y-intercepts, horizontal asymptotes, and vertical asymptotes. Now, it's going to be an advantage to express this in both factored form and unfactored form. It's already unfactored, so I'm just going to factor the numerator and denominator. In the last example, it was already both in factored and unfactored form because you had linear values. In this case, the numerator looks like it could be 4 and 1. And if they're both negative, they would multiply to positive 4, add to negative 5. In the denominator, I'm going to have x plus 2 and x minus 2. Which means for my x-intercepts, this is where I have zeros in the numerator. Well, I have zeros in the numerator at 4 and 1. So I'm going to plot those points, 4 and 1. Y-intercepts, it's still the ratio of those constant terms. So if positive 4 over negative 4 is negative 1, so 0, negative 1 is my y-intercept. Horizontal asymptotes, the coefficients here are 1 and 1. The degrees are equal, so I'm just going to take the ratios of those coefficients. So the horizontal asymptote is y equals 1. Now, the vertical asymptote. The vertical asymptotes occur where you have zeros in your denominator. And I have zeros in the denominator at x equals negative 2 and x equals positive 2. So negative 2, like right there, positive 2 right there. Now, I need to fill in my curve. I could use a sign chart, but I just don't think it's necessary again in this case. Because on this part, my graph either has to bend toward the curves this way, or it has to bend toward the asymptotes this way. The problem is, it can't be down here, because I would need to have another x-intercept for that to happen. So since that x-intercept doesn't occur, that's not part of my graph. So my graph is up here. Now, in this one, my graph could be like this, it could be like this, or it could be like that, or, it could start down here and end this way. I think there's clearly only one way this is going to happen. So, it's not that one. It's not that one. It's going to be that one right there. I'm going to pass through those points in kind of a shape like this. Now, there's some other principles that kind of help me lead to that as well. If you think about multiplicity of your zeros, the asymptotes have multiplicity as well. And if the multiplicity is 1, then that means you change sign over the asymptote. So you're guaranteed that would be the case. All right, moving on to the next one. My graph is either that or it's that. And I think it's pretty easily seen that it's going to be the one underneath because I have that x-intercept that I have to pass through. So it's not going to be this one. If you check these on your calculator, let's take a look at the graph. So x squared minus 5x plus 4 divided by x squared minus 4. You'll come up with something that is pretty similar to your graph, but not always exactly like your graph. It's definitely enough to verify that you have the right picture, though, because you can clearly see this portion right there. And here's your asymptote. Then you have this portion here, like that, another asymptote, and then the resolution of the calculator here is kind of falling apart, but you see that portion of the graph over there as well. And certainly it doesn't show the horizontal asymptote, but you can kind of visually see it right there, and I may have it a little higher than it's supposed to be, obviously, but you can kind of get an idea where it is. So use your calculator to check your answers. I wouldn't really rely on them to come up with the answers in these cases here. So, all right, let's move on to the next problem.